I'm not sure what to do here. Root test is equal to 1. Okay, let's have a look. Here we have this infinite series, and because the n is in the exponent right here, so maybe it's a good idea to use the root test, right? Let's give it a try. So by the root test, what we are going to do is we are just going to check the limit as n goes to infinity. Not just this expression though, but the nth root of that expression. So the nth root of n minus 3 over n plus 1, and then raised to the n plus 2 power. Alright, for the nth root, it's the same as 1 over n power, so we can actually just look at this power and divide it by n. So this right here is the same as the limit as n goes to infinity of n minus 3 over n plus 1 raised to the n plus 2 over n. Alright, so let's see. If we plug in infinity into all the n's, let's see what will happen. When we plug in infinity into the inside, you see that minus 3 plus 1 doesn't matter, so it's just this and that. We will just get 1 inside. And then for the exponent here, as n goes to infinity, we just care about this n and that n, and again that will give us 1. So that will just give us 1. So this limit is equal to 1, but this 1 is bad because for the root test, if the limit is equal to 1, this right here does not give us any conclusion. Does it diverge? Does it converge? We don't know. So inconclusive for the root test. So what do we do though? Well, have a look. Notice that right here n and n right here gives us 1. Before we do the root test, let's just take the limit test, the limit of this term. And this right here is also called the test for divergence. So TFD, test for divergence. All we are going to do is we are going to check the limit as n goes to infinity of just this without the nth root. So let's see, we will have n minus 3 over n plus 1 raised to the n plus 2 power. Well, if we just plug in infinity into all the n's, let's see what will happen. For the inside, this and that, yes, it will give us 1. If we put infinity right here, infinity plus 2 is infinity. What's 1 to the infinity? Well, the answer is not equal to 1 necessarily, right? It's one of the indeterminate forms, right? It's on my shirt. So we cannot draw any conclusion yet. We will have to do more work for that. So what do we do though? Well, let me erase the board. Okay, so how do we do this though? Well, here is the deal. I would like to tell you guys one of the secret weapons when we do limits, and I call this the fact. Right? Whenever we have a 1 to the infinity power like this situation, keep this in mind. So what do I mean? I'm trying to say that the limit as some variable t approaching infinity of 1 plus some number a over t raised to the bt's power. This right here is very nicely equal to e to the ab's power. Alright? So let's first somehow put this into this form. And to do so, notice that we have n to the first, n to the first. Let's just do polynomial long division. So right over there, I will just show you. If we have n minus 3 divided by n plus 1, n and n we need 1. 1 times that is just n plus 1, and we subtract. And negative 3 minus 1 is negative 4. So for this right here, we can write it as the limit as n goes to infinity of the inside expression is going to be 1, and then the remainder is minus 4, so it's minus 4 over the original denominator, which is n plus 1 here. So it's just some algebra for the inside, and then raised to the n plus 2 power. So now you see the 1 matches. So it looks like we have negative 4 for the a, but not quite, because we have what? N plus 1 here, and also n plus 2 here. So we have to just fix it a little bit. It's not bad to fix this though. To do so, I will just tell you, we can put t equal to this denominator. So t is equal to n plus 1. Then in that case, we can say that, well, n plus 2 is equal to t plus 1. right? Just add 1 to both sides so we can get a n plus 2. So this right here becomes the limit as n goes to infinity. We will get infinity plus 1, so t will also go to infinity. And then we have 1 minus 4 over that is t. And then raised to the what? N plus 2 is t plus 1. All right, to continue, I'm just going to take this and then do the work right here. For the t plus 1 in the exponent, we can break them apart. Check this out. This right here is the limit as t goes to infinity. I'm just going to have this to the t's power first. So we have 1 minus 4 over t to the t's power, and then by the rule of exponent, that's the same as multiplying by 1 minus 4 over t to the first power. Now check this out. We have a limit of a product. Could that be the product of limits? Yes, if both limits exist. So if you just go ahead and look at this as the limit of t approaching infinity of 1 minus 4 over t to the t's power times another one. If both of them exist, then we can just do like this. Very nice. Have a look. What's the red part? Well, we can use the fact for it. Notice the a is what? Negative 4. Yeah? And then the b is what? It's just 1. So for the red part, this right here will be equal to e to the negative 4 times 1. So it's just negative 4. And then for this right here, if we put infinity to here, 4 over infinity is 0. So 1 minus 0 is just 1. So it's just that times 1. So the limit for that is just e to the negative 4. Good. But now what though? Be careful when we are doing infinite series. It's not about the computation. It's about the reasoning. So now check this out. When we are doing the test for divergence, we take the limit of this term as n goes to infinity. And then we end up with e to the negative 4, which is not equal to 0. That's the key. Right here, we are going to say this is not equal to 0. And this is very nice because we get to draw a conclusion with regarding the original series. So I can tell you that by test for divergence, the original series that we are trying to do as n goes from 6 to infinity. By the way, I should also mention that the starting n value doesn't matter as long as we don't mess up the inside. If you don't have like negative 1, you don't have the 0 on the bottom, it's okay. You can start with n is equal to 200. It's still the same argument. So by test for divergence, the original series, let me just write that down one more time. This thing right here, diverges. Right? This thing right here, diverges. Don't just say diverges. Make sure you also provide a reason. Remember, if we worked out the test for divergence, the limit, as long as it's not equal to 0, we get to draw a conclusion. And the conclusion is this thing right here diverges. And the idea is that eventually we're just adding a bunch of non-zero numbers. So of course that will go to infinity. But if this right here is equal to 0, then unfortunately that would be inconclusive as well. But anyway though, hopefully this right here is helpful. If you need more help with infinite series, definitely check out my 100 series video. That's it.